If bloating is something affecting you, the first thing you should know is that you're far from alone. In fact, according to a recent survey, 30% of the entire adult population have to constantly deal with a bloated stomach too. The severity of bloating can also vary considerably, from mildly uncomfortable and annoyingly unaesthetic to extremely severe and even life-altering. Regardless of where you fit in, my goal with this video is to give you everything you need to get rid of bloating. Specifically, we'll look at the two most powerful ways: the gut microbiome and diet. A lot of this research is very new, and especially regarding the microbiome, also has major implications for overall health, longevity, and even helps explain why our Western diets are associated with an increased rate of so many conditions beyond just bloating. That's why in part 1 of this video, we're laying the foundation by truly answering the question of what is bloating and seeing for ourselves what causes bloating, because it turns out there's way more to it than just gas. If you really don't care about anything other than the specific ways to reduce it, feel free to skip ahead to the microbiome section. Otherwise, let's get into it. Every mammal has a digestive system that's a bit unique, and humans are no exception. Like with the others, ours is perfectly adapted to give us certain advantages and disadvantages based around the kinds of foods early humans would normally eat. However, with so much change to our diet over the last several decades, also happening to coincide with a dramatic increase in the number of people experiencing bloating, I think it's important to quickly address why our digestive system works the way it does. Ask someone to name the one thing that sets us the most apart from other mammals, and they'll probably say our much larger brain. But what less people realize is that while our brain grew, our digestive system also shrunk. Reason being, specialized organs burn so much more energy that to power a bigger brain requires cutting down on something else. The GI tract was the obvious choice. Since being smarter made us better at finding high-quality, energy-dense food, we'd no longer need to dedicate as much digestive space to fermenting the high-fiber, low-energy bulk food sources that less intelligent primates rely on. Complex carbohydrates, which include these fermentable fibers, have gained a reputation, often dominating the viral lists of top foods that cause bloating. But the reason why I started things off with what makes our digestive system unique is because there's two sides to this. After all, it's not as though the foods which people blame bloating on actually have some secret air supply trapped inside them. Gas that builds up in our gut is really a result of the interaction between the food and our digestive system, where in some people with bloating, something is clearly going very wrong. I get why people tend to focus mainly on controlling the food side of this equation, because some foods certainly have more gas-making potential than others. But there's also another factor at play that's often forgotten. The widely diverse community of beneficial microbes and bacteria in our gut also play a major role in digestion and health. So much so that our microbiome has even been referred to as the forgotten organ. When a food you eat produces gas, what's actually happening is that some of these helpful bacteria are breaking it down through what's called fermentation. They're the ones actually making this gas. There are major reasons this fermentation benefits us, which I'll get into later. But the point right now is we all have a slightly different profile. Everyone's microbiome is unique. Because the ways this food is broken down and the gas is produced are directly dependent on which particular species are the ones doing it, shifts in a person's microbiome have been shown to majorly impact almost every digestive mechanism, including the ones that cause bloating. So in a strategy to reduce it, alterations here matter just as much as food choices. Because unfortunately, our smaller and more sensitive GI tract, with less space dedicated to them, makes these delicate microbial populations all the more prone to negative disruptions. So there's not one, but two major variables we'll be looking at. But now, let's see based on the newest research how they actually work together during normal digestion and where this breaks down in cases of bloating. A key takeaway from the research reviews I've read is that bloating as a symptom can have more than one cause. Here though, I'm going to focus on a typical example of functional bloating, which is the most common. This is bloating without any other symptoms or underlying cause. Let's imagine two friends go out to a restaurant. One, a textbook example, constantly dealing with frustrating and uncomfortable bloating. Often, his stomach will look nice and flat in the morning, but by the evening, looks like it's bulging outwards, usually accompanied by an uncomfortable and sometimes painful full feeling. The other will be a normal, healthy individual who, for this example, won't be experiencing any bloating. Suppose they just ate the exact same meal. The digestive process starts out mostly the same. Initially, the stomach fills up, mixing acid in with the swallowed food. It uses gentle contractions to grind everything up into a sort of acid smoothie called chyme. About 40 minutes later, the chyme is ready for the next phase and begins to empty into the small intestine. Here, we release enzymes and bile to break up proteins, fats, and simple carbohydrates so they can be rapidly absorbed by the cells that line our intestinal walls, called epithelial cells, absorbing either directly into them or through specialized gaps between them, called tight junctions, which allow for larger nutrients to pass through to the bloodstream, but must be tightly guarded so toxins don't get through. Ideally though, these toxins shouldn't even be getting near them, thanks to something called the mucosal barrier, purposely designed to keep these toxins back, but to allow nutrients through. Epithelial cells are also attached to specialized nerves, letting them act as monitoring stations, feeding constant updates into the local nervous system, called the enteric nervous system, which itself feeds information back and forth with the brain, coordinating everything together. These cells monitor pressure created by food and gas buildup, stimulating smooth muscle contractions that push everything along and relieves the pressure. This is what keeps everything moving smoothly through the small intestine. But with most simple nutrients being absorbed so quickly, it's primarily just the ones in complex carbohydrates, called dietary fiber, that move on to the final stop, the large intestine. And speaking of gas, it's here that the majority of it is being created. While some CO2 is released earlier on, as special bicarbonate biles neutralize stomach acid, the vast majority of intestinal gas is made here in the colon. This is where a diverse array of gut bacteria get their turn to break apart and burn for energy these complex carbohydrates, which we simply couldn't. They're able to do this because they have proprietary digestive enzymes, which we can't make. As this gas builds up, the epithelial cells feel this pressure and increase contractions to move it through and out. Although some certain gases like hydrogen can also absorb right through the intestinal walls and into the bloodstream to be exhaled in our breath. So far, so good in our healthy individual. But what about our friend? Let's see how he's doing. And, at this point, already feeling a significant amount of discomfort, a painful sensation of fullness, and his abdomen actually appears to be physically a bit distended. Sadly, this is how it often is. Despite eating the same meal, one individual can experience significant bloating, while another is totally fine. So what's different about the way they're digesting? Research overviews often identify 3 subtle mechanical differences. First, there appears to be a strange reduction in propulsive contractions. In other words, the gas isn't moving. Epithelial cells, which are supposed to be detecting this pressure and signaling contractions, for whatever reason, aren't doing it as well. In fact, several studies have confirmed that even when an equal amount of gas is manually pumped into the digestive tracts of healthy individuals, along with frequent bloaters, those in the bloating groups respond far worse. In one study, immediately following the gas infusion, nearly all of the bloating subjects reported feeling an uncomfortable bloating sensation, and many of their abdomens became visibly pushed out and distended. Meanwhile, in the healthy volunteers, 80% of them didn't feel anything and had no physical response. Another study took the same technique, but instead timed how long it would take their bodies to get rid of the gas. They discovered the GI tract muscles in the healthy individuals quickly got it out, whereas in the bloating group, this gas transit took much longer. And this brings me to the second difference, and that's in how sensory information from the nerves in the intestinal wall is perceived by the brain. For sufferers of functional bloating, there appears to be an oversensitization going on in these nerves, termed visceral hypersensitivity, where the sensation of something that would be unnoticeable in a healthy person can go so far as triggering significant pain in functional bloaters. Okay, but wait. Why am I discussing these seemingly small details when the major issue to be discussed here is all the excess gas they're making, right? Well, actually, they aren't. It surprised me to learn this too, but in fact, people with functional bloating, in many instances, don't produce any more gas than a healthy person would from the same meal. Even modern studies which use advanced image analysis software to compare CT scans have found minimal correlations between an actual excess of gas production and bloating. And although their abdomen can indeed become visibly pushed out, this measurable aspect, called distension, is only found in 50% of those experiencing bloating. In the others, they still have the feeling, but without the physical change. Sadly, this lack of visible evidence meant until even just recently, patients seeking relief for these symptoms would often instead be diagnosed as having a mental disorder. But if we go back to the healthy example for a second, where in the colon the majority of intestinal gas production takes place, it's been discovered that to deal with it, the digestive system has one final trick. Without us realizing, nerves originating in the epithelial cells can automatically trigger a coordinated muscular reflex, one that feels so natural that if it wasn't for the advent of CT scanning technology, we might not have ever even realized it exists. As gas begins to build, the muscles of the anterior abdominal wall suddenly start to flex, while simultaneously the diaphragm relaxes. These scans from a recent study reveal the shocking amount this reflex can expand the space available for this added gas. While from the outside, it's nearly impossible to even tell the difference. But back to our typical bloating subject with distension, not only is this reflex not occurring, it's reversed. In a reaction where their diaphragm actually starts pushing downward as the internal oblique muscles relax. Experts call it abdominal phrenic dyssynergia. When this reversed reflex occurs, their midsection will distend, literally bulging outwards, creating the illusion that your gut is being pumped up with gas like it's a balloon. These three changes to the digestive system are most typical of what's actually happening under the surface in someone that's constantly dealing with troublesome bloating. There's one last thing to mention about our healthy subject though, because although he didn't have any bloating in this example, no one is immune. Healthy or not, we can all get bloated. It only takes a few accidental choices. This is the category I personally fall under. So, whether you want to look your best by minimizing the small amounts which we all seem to have after certain meals, or you just want to make sure you don't become like our friend here, something that I hate to say could easily happen to anyone also, I'm going to be sharing strategies for us less frequent bloaters too. The gut microbiome is, in my opinion, the missing piece to solving the bloating puzzle. Even more so than our food choices, because think about it. If it was just a problem of eating the wrong foods, then how come a food that causes bloating in one person doesn't in another? We just saw how bloating isn't as much about having more gas as it is about incorrectly reacting to and handling gas. So, what we really need to look at is the control system that manages this, which is referred to as the microbiome gut-brain axis. And as the name suggests, the gut microbiome, with its trillions of beneficial microbes and good bacteria, has recently proven to be an integral part of this system. The first thing to realize is that despite there being thousands of different bacterial subgroups and species that have been identified in people's microbiomes, the average person will only have a small fraction of these. One study analyzed fecal samples from 124 European adults to compare their microbiomes. And while over 1,000 unique species were identified across the whole group combined, any given person only usually had about 160. Differences are even more profound when you compare us with people that still consume a less processed diet, more similar to what our ancestors would have traditionally eaten. Here, they're shown to have many more types of good bacteria. And coincidentally, the rise in bloating we've seen in the developed world appears strangely absent as well. Experts blame our processed Western diet, love of antibiotics, and borderline obsession with sanitizing literally everything for why we are suddenly seeing so many people's microbiomes missing key species and shifting into a state of disruption. Just how surprisingly dependent our health is on having the right bacteria species in our gut is only now starting to be fully recognized, as each day more links are being discovered. On the positive side, the presence of certain species have been linked with everything from improvements in mood to lifespan and even social skills. Increases in the species Lactobacillus appear to be particularly associated with significant reductions in bloating and distension, while in a totally different line of research, also shown to enhance levels of mood-boosting neurotransmitters like serotonin and GABA. Other species have been shown to synthesize for us key vitamins like B12 and vitamin K. Studies across the world on the lucky few that live to be more than 105 years old have found the taxa Akkermansia consistently at levels far above average. So I guess that's good news for you if you get tested and find that. On the negative side though, dysregulation and the increases in harmful species which it causes has been associated with cognitive impairment, anxiety, premature aging, inflammation, and of course, digestive issues like bloating. So why do gut bacteria influence so much? It all has to do with how, over time, our bodies became so used to having specific bacteria around that not only did we start relying on various ones to play key roles in breaking down nutrients through fermentation, we also began integrating various metabolites and byproducts they produce into the signaling systems that control and keep the whole digestive process running smoothly. All in all, hundreds of mechanisms that regulate our digestion have been found to directly rely on the involvement of specific types of bacteria. This integration explains why a disruption in our microbiome's balance can significantly affect how frequently you'll experience bloating. And here's the good news. The same way your microbiome can shift into a disrupted state, there are also ways to switch it back. Studies on animals purposely raised from birth in sterilized conditions so that they have no microbiome at all are a great place to see these links. Animals raised germ-free like this immediately show major differences. They don't grow as much, actually resembling nutrient-deprived ones. They have impaired immune systems, dysregulated hormones, and even show altered brain function. But the pathways that relate back to bloating are the ones I really want to focus on. Motility, the ability of intestinal muscles to pass along food and gas, in these animals without gut bacteria, is observed to be much slower and impaired, just like what we saw in humans with functional bloating. See the data for yourself from a recent mouse study. Other research on these germ-free mice has also shown similar increases in that visceral sensitivity, where oversensitive nerves perceive normal digestive gas as suddenly painful. Research shows these mice without gut bacteria experience something very similar. And to top it all off, it's even known to be a long-standing observation that germ-free animals will often have a visibly distended abdomen. While human studies can't go to the extreme of fully eradicating someone's microbiome, even just disruptions in it are often enough to cause bloating too. You see this in studies that follow people recovering from intestinal infections, like salmonella. Between the damage caused by the attacking bacteria itself, and also the antibiotics that usually follow, even after the infection is gone, the microbiome will often be left in shambles for long after. When research also emerged showing that even after recovery, 30% of individuals experience lingering and unexplainable issues with IBS and bloating, this major connection really started coming into focus. Further studies began to find distinct patterns in the bacterial populations of those who did and didn't experience these lasting symptoms. But what really topped it off is the newest research showing that if these microbial gaps found through testing were corrected with probiotic supplements, the lingering symptoms would often disappear too. Now, I'd love to be able to say that they found one specific bacteria species missing in all those with bloating problems. But researchers are quick to remind us that the gut microbiome is highly diverse and complex. So imbalances won't always look the same. An unpleasant symptom like bloating may easily arise from two seemingly opposite profiles. Given just how diverse and complex the imbalances can be, having your gut microbiome tested and evaluated properly can be extremely helpful to determine what species needs attention. Different bacterial groups each have their own standard reference ranges, so seeing that you're out of whack anywhere can be a cause for concern. To help focus my research for this section, I actually spoke directly with an expert who's overseen the microbiome testing for thousands of people. She's the chief science officer for a popular microbiome testing company, which I've used myself. Working with everyone from those with highly specific digestive issues to those that simply want to maximize their body's overall health and longevity, I felt would give her a real-world perspective on what imbalances are most commonly seen in bloating. Right away, she started outlining the most common microbial profile they find in frequent bloaters, where several species of beneficial SCFA-producing bacteria become depleted, and in their absence, a coinciding increase occurs in proteobacteria, often to harmful levels. I personally had this testing done late last year. While I was fortunate enough to not have such a profile, bloating is also thankfully not something I typically experience. After having spoken with her, I managed to get a sponsored affiliate link to their microbiome test, so I linked it below if you want to take it too. It's an at-home test where they basically mail you a sample bottle and you send it back with a small sample that they analyze. If you do happen to get a profile that shows an imbalance, they'll recommend individualized food and probiotic supplement strategies to resolve it that you can start implementing right away. Probiotics are actually going to be the most direct way to fix and replace a microbial deficiency. They are essentially a class of supplements which contain billions of living cell cultures for a specific species you're looking to introduce or support. The idea with getting testing done is that then you'll be able to focus on bolstering the particular communities that you're deficient in. Although not as precise, if for whatever reason you don't want to get tested, but still want to take action, you might consider trying a more general probiotic supplement. A review paper on functional bloating pointed me to a recent double-blind study where bloating patients supplemented with Lactobacillus acidophilus and Bifidobacterium, two well-studied probiotic species. Supplementation resulted in sizable improvements in their bloating symptoms. But after having that call, I wanted to understand a bit deeper why this specific imbalance commonly leads to increases in bloating, and I actually found the same profile cited in a paper. This led me down a research path that was honestly pretty mind-blowing. SCFA producers, like most of the bacteria we've talked about, break down various complex fibers for energy. But what makes this group so special, though, are actually the specific byproducts they produce, SCFAs, short-chain fatty acids. While we've always pretty much been told that fiber isn't a source of energy for us, I was genuinely surprised to learn that that's not true at all. Because although we don't directly burn the sugars locked in the fiber, these SCFA byproducts are actually a significant fuel source for us. Far simpler and much smaller than what's found in dietary fat, it's now becoming clear that these SCFAs play key and often irreplaceable roles across the body. And these bacteria are pretty much our only source for them. After their release, they fuel nearby intestinal cells, but also absorb through to the blood, where they deliver power to the entire body. Their energy contribution is reported in studies to account for up to 10% of a person's daily burn, but that is assuming an individual is consuming enough fermentable fiber, which until quite recently was all but guaranteed. Although our body gambled by reducing the space dedicated to fermentation, the expectation was that these easy-to-find, low-quality fibers would always still be there, with their SCFAs being our most reliable nutrient source. Suddenly taking them away can have far-reaching consequences, and has been linked to disruptions in the blood-brain barrier's permeability, fat storage, appetite regulation, cholesterol levels, and even diabetes. I have to say, this seriously opened my eyes. Despite this video being about bloating, learning this really jolted me into taking my microbiome very seriously, both getting it tested and adopting dietary strategies to promote SCFA production, which is part of what we're going to cover in the next section. Believe it or not, epithelial cells that get so messed up in the mechanisms behind bloating directly rely on the bacterially produced SCFA butyrate for a shocking 60 to 70% of their energy. Butyrate also directly triggers the assembly of tight junction proteins. If there's not enough of it, it causes a loosening of these pathways that makes it easier for toxins to leak into the bloodstream. It's also needed to keep inflammation down, partly through its role in activating G protein-coupled receptors. Without it, low-grade inflammation occurs, which can impair the ability of the epithelial cells to work as sensors. Reduced motility of gas, messed up muscle reflexes, and added sensitivity can all be explained by the resulting underenergized, inflamed, and dysfunctional enteric nervous system. Also, when many of these specific bacteria break down nutrients, they're somewhat unique in that they don't make any gas. It's no wonder then that a lot of the most effective probiotic supplements for reducing digestive issues contain species of these SCFA producing bacteria. Asking for a smooth digestive process when all the sensory systems are out of whack is like smashing the cameras and sensors on your self-driving Tesla and then expecting it to drive itself smoothly down the highway. And if they become depleted, it leaves space for other bacteria to increase in numbers that, unlike the SCFA producers, create gas and irritating liposaccharide byproducts shown to trigger even further inflammation. Whether you deal with major bloating or just a little occasionally, it never hurts to know if an imbalance is at play, and then what specific species to focus your probiotic supplementation on. Like I said, the microbiome testing lab I've personally used is linked below. Instead of going into a physical location to have it done, I like these kinds of places that do things by mail. They'll report back and show you what specific microbes you already have enough of, and what probiotic species and dietary choices you should consider to fix whatever deficiencies they find. Diet is the other half of this puzzle. So now let's explore the ways we can optimize our food choices, which affect bloating both directly through the delivery of gas-producing foods and indirectly by causing shifts in the microbiome as well. There are two different ways to think about using food choices to reduce bloating. First, we'll cover a short-term approach for maximum bloat reduction over just a short time frame, like what you might want to do before a weekend trip to the beach, a photo shoot, or a date. The second approach will focus on achieving a long-term reduction in bloating through more permanent dietary changes designed to work with the microbiome. So looking for maximum short-term reduction for just a day or two, eliminating as much gas production as possible will still be the single most effective approach. Because the fact still remains, without any fuel to produce gas from, there's nothing to cause bloating. A research review on bloating sets up this idea in a passage where they remind us that even healthy people can get bloated if they eat a meal that's particularly large or that contains too much food that's fermentable. So avoid large meals in the lead up, that's easy. But what about these fermentable foods? Well, that's a bit more complex, mainly because there are so many different categories we use to classify food. There's a lot of overlap and yet nothing that perfectly matches up with what can and can't be fermented. Dietary fiber is often used for a lack of a better term, since it describes any of the carbohydrates complex enough to make it past the small intestine. But not all dietary fiber that makes it to the colon is actually fermentable. Some is simply too tough. The microbiomes of some other animals like cows can do it, but they might be an example of an animal that prioritizes gut size over brain size. When research in the 80s and 90s began to show that certain carbs in the middle zone, despite being too simple to be considered fiber, like the monosaccharide fructose and the disaccharide lactose, were poorly absorbed by many people, resulting instead in rapid fermentation with concurrent complaints of bloating and distension, a list of rapidly fermentable molecules like these was started and gradually expanded over time. Collectively termed FODMAPs, not surprisingly, studies show that if enough are consumed, even healthy individuals experience a rapid increase in gas production, flatulence, and bloating. And in short-term studies, individuals with IBS following diets that cut out foods high in FODMAPs have shown significant improvements. For example, in a study that compared the efficacy of a low FODMAP diet versus the standard medical advice given to IBS sufferers, 76% of those following the low FODMAP diet reported satisfaction with their symptom reduction, something reported by only about half of the other group. Digging into their individual symptoms, the number reporting bloating-specific improvements further increased to 82% in the low FODMAP group. The traditional advice, which still relied on vague terms like dietary fiber to make recommendations, simply didn't stand a chance. Since first being suggested just 15 years ago, the low FODMAP diet has quickly risen to prominence as a leading way to majorly cut down bloating. Since FODMAP content varies between foods, extensive lists are out there which provide a quick way to reference whether a food is high or low in them. So if your goal is maximum short-term bloating reduction, avoiding large meals, and limiting yourself only to foods on the low FODMAP list, although often criticized as an over-restrictive approach, will probably still be the most powerful thing you can do. Aside from maybe fasting completely, but that's even more restrictive. Recently, I filmed something that required me to wear a shirt and tie. I actually did do a 60-hour fast, which I broke the night before. Then I purposely avoided eating any high FODMAP foods that night and the next morning before the shoot. The fast probably wasn't necessary for abdominal bloat, but provided a complete reset and definitely reduced water retention, which itself is another thing I want to talk about in a future video, since it does also contribute to the appearance of bloating. As we move on, I've also included a link to a list of high and low FODMAP foods in the description as well. But with plenty of evidence for short-term effectiveness, why are many dietitians beginning to caution against long-term FODMAP restriction? Well, based on what we discussed before, If a Western diet low in fermentable fiber leads to microbiome dysregulation, and by extension, digestive upset, does it really make sense to think that further dropping down our intake would lead to long-term improvements? This shotgun solution can for sure reduce production of poorly managed gas, but does nothing to repair the underlying issue. This strategy, over time, will starve out the good bacteria, like SCFA producers, even further, long-term potentially causing even worse bloating. For just one example, in the absence of fermentable fuels, we know populations of those good bacteria that produce SCFAs fall. SCFAs also play a key role in the production of the mucosal barrier, which protects the intestinal walls. And what's worse, if starved for fermentable fuel, some of our best bacteria, like the Akkermansia, can, out of desperation, actually turn to using this mucus as a fuel of last resort, damage that results in even further inflammation and upset. So instead of looking to shift diet in a way that minimizes short-term gas production, what if we find foods that will actually help support healthy bacteria, especially the ones that don't make gas? In 2016, the International Scientific Association for Probiotics and Prebiotics formalized a definition for a new class of nutrients that do just that. These special foods are called prebiotics, not to be confused with probiotics. Unlike probiotic supplements, which contain living bacteria, prebiotics are foods that take advantage of the fact that what we eat has the power to shift the microbiome too. To meet the definition of a prebiotic, a food must of course contain components that are fermentable. Additionally, research needs to show that eating it disproportionately benefits only specific species of good bacteria that have already been proven to have beneficial effects on us, like certain SCFA producers, which we talked about. Since this is also new, the list of foods that have achieved prebiotic status so far is still small. It includes a handful of fruits and vegetables, including asparagus, leek, banana, chicory, and grains like oats and wheat. Just a few fermentable molecules are usually responsible for these effects, and beyond the food sources, you can often also find refined versions of them being sold as prebiotic supplements. Inulin, fructooligosaccharides, and galactooligosaccharides are the three primary examples, falling mostly into the oligosaccharide group. I'll put up some of the minimum doses which have shown effects in the studies I've seen. Now, this doesn't mean other bacteria species can't ferment these molecules too, but instead that a beneficial species simply happens to be especially good at it, usually due to a unique enzyme they make. This unfair advantage lets them outcompete the other less desirable and harmful bacteria, resulting in positive shifts in their numbers. Relieving imbalances and the issues they cause means you'll then be able to better handle all other fermentable foods too. So don't think of this as a strategy where prebiotics are the only things you eat. Instead, see them as something that you add to improve your ability to eat whatever you want. But remember, even once you start consuming a prebiotic food, microbiome shifts aren't instantaneous. So if the beneficial species are depleted, then even despite their advantage, in the beginning there often won't be enough of them to fully utilize this new fuel. Explaining studies like this one, where initially when people began consuming prebiotic food, they produced more gas. But after a week or two, as their microbiome improved, gas production returned to baseline. Here, the beneficial population that saw the largest increase were bifidobacteria, SCFA producers which do their fermenting without producing gas. Something I really appreciated about the company that I used to test my own microbiome was that they also provided me with prebiotic food recommendations as well. Now, hopefully you see why just cutting out fermentable fibers and FODMAPs forever doesn't really make sense, since many of these great prebiotics would technically be excluded for being oligosaccharides. As we near the end now, one last thing I'll add is that there are still a few FODMAPs you might want to be careful of. In a review paper on bloating, the author advised special caution when it comes to lactose, fructose, and sorbitol. since a large proportion of people tend to have sensitivities to them. So that's also something to keep in mind, especially with high fructose corn syrup suddenly appearing in what feels like everything. So to wrap up, I've put together a recap of all the strategies we covered. You can really see how everything is so interconnected. With so much research being done each day, it's definitely something we may be revisiting in the future, as I found a lot of other information related to hormones and how they can affect bloating also. But for this video, I wanted to stay focused on just the most controllable causes. But if you want to see that, or anything else I post, consider subscribing. Or who knows, you may never see me again. Also, feel free to follow me on my personal Instagram, shoot me a DM, like all my photos. It's up to you. Some pretty cool raving pictures on there. So I hope you enjoyed that, and until next time, D-Man signing off.